ever accelerate. It presents both opportunities and a lot of challenges. So we've got imagery, we're increasingly use imagery, we're increasingly extracting information from that in smart and intelligent ways using sort of things like deep learning and so on. I'm not going to go through all these topics now in detail because I'm conscious, by the way, that I'm the last person between you at lunch, and I wouldn't like to delay your lunch. But this afternoon's sort of sessions will try to explore these areas in detail. Actually, Ed's own sort of presentation was quite a nice lead into some of my things, because things like natural language and processing of that are going to become a lot more focused. But even there, they present new challenges. So as we start to process natural language, one of the immediate problems that we get is how do we disambiguate certain terms? If I talk about Southampton, what am I really talking about? Which Southampton? There's dozens of them across the world. Or I might be talking about a ship called Southampton, or even sort of Walsall Southampton. If we look at 3D, then that's actually quite a good example of both where lots of people want 3D, but actually they're not sure why they want it. So we're not very good at capturing it. So this is quite a good theme that actually goes across most of these boxes as well. We're not actually very good at capturing it in an efficient, cost-effective way at the moment. We're not very good at modelling it, and we're not then very good at interacting with it. But apart from that, 3D is almost certainly solved. We have sensor nets, drones, and dozens of other technologies coming along all the time. And actually, one of the ways that we then try to transmit that, of course, is one of the items we're not going to be talking about today, which is the underlying infrastructure for all this, which I think actually another probably special occasion is that we're probably the only two people in the audience, collected here today, really, in the geospatial business that don't really like SDIs up here today themselves. Because I always felt they're a great way of not talking to the rest of the world. And actually we need to be talking to the rest of the world and opening it up. And one of the challenges for the future is also how we migrate from SDIs to technologies that actually support what I would call the data infrastructure and what Ed would call the web, because actually they're probably the same thing. Another way that we need to look at this is around models for management. Actually, yes, you missed the top. Just noticed actually the display. This should say models and management. So it's around databasing at one level. Lots of different database technologies are coming along. We used to have just one choice really when it came to databases. They were called relational ones, and now we're spoiled for choice. But actually, none of those technologies have matured yet. That's not to say they're not usable, but we haven't seen the end of their development. And that can include things like graphs and document databases and so on. One of the most important things that we don't do very well at all is build adaptable systems. We all talk about how the future is unpredictable. We don't know what the future is going to be like. I think it was Niels Bohr that said that predictions are difficult, particularly about the future. And he's right. But what do we do? And this is not just in the military, but industry generally, we build systems that we can't then adapt. And as a computer scientist, back in the day when I was learning my trade at university, that was a long time ago, and we still had 9 planets there. But then we were taught how to make things go quickly. We were never told how to make systems adaptable. Actually, I don't think we teach that today as well, because actually we don't really understand how we build systems to make them adaptable to the future. It's a hard problem. But I think some of the technologies that are coming along are making that easier. We need to look at them and seize them and see how to apply them. There's 3D again. Spatial temporal, we don't really build very good spatial temporal databases, but there's more and more of that information has a temporal element to it, as actually Ed again sort of demonstrated, really. We want to do prediction, we want to manage things like uncertainty, which again we don't do very well at the moment. This one says interaction. And that really covers all forms of interacting with geospatial data, which is around maybe visualization, this is including 3D, which you can see at the top of the screen there. Certainly, we can also represent spatial data as text. we can have conversational interaction with it. So why should we just receive data? Why can't we ask it questions as well? It might involve touch, virtual and augmented realities, human factors, and so on. Again, lots and lots of different technologies, and all of these have a relevance to the geospatial world. Actually, one of the things that's pretty worth saying about technologies is that when you look at what's special about the spatial, the geography, not many of the technologies, and we've been really focused on the technologies over the years, which really is why we put this one as also very important, which is people and places. So it's an attempt to try to really reopen the debate about the human element to all this as well. How do we represent space and place? How do we represent and understand the vernacular so that as we need to have much better and closer understandings of the urban areas, for example, but the people that live there tend not to use many of the local, the terms that officialdom has imposed upon them. They have their own descriptions of local geography, their own names, their own understanding of extensive places. So if I refer to Oxford Street, for example, in London, I might not be referring just to the street, I might also be referring to the area around that. But I have to understand which communities use those terms in that way. And that's really all I wanted to say at this point. In the afternoon, we'll go for lunch now. In the afternoon, we will have a series of lightning talks from members of the audience. Those of you that haven't delivered me the thing, you can do that to me now, I'll load it onto the machine. One of the things I think, well, I'm only going to put this slide up once, and one of the things that's really important to get across from this is there's quite a lot of very different subject matters going on here. And that really reflects the very broad way that we will probably be addressing some of the research problems in the future as well. So, and this is just really some of those issues. There's something there about chemotropy, there's something about space-time, there's something there about deep learning, and so on. And all of these technologies and research areas, really, we need to operate and bring together in some way. What we don't foresee, by the way, at the end of this is a new system, sort of shiny system, throbbing in someone's face somewhere. This is about understanding what research we need to commission, what problems that we're meant to be approaching, and so that then we'll take the outputs of those research, those bits that can be implemented in existing systems or in new ways of doing things immediately, we will do. Others may be just building, they may be just applying components to further research until we finally are able to deliver something operationally as well. So we see this as a long-term thing which may have short-term benefits, but it's also like to have longer-term benefits as well, because we want to push things out further than we've gone before. So thank you for that, and off for lunch. I think we're allowing 50 minutes for lunch, so yes.